partial fraction decomposition. What this means is we are going to find the two fractions that would have added to give me that. Now let's think about adding fractions. Adding fractions. If I had 2/7 plus 3/5 and I wanted to add them together, well, I would need to have a common denominator. So I might multiply this one by 5 and this one by 7, and you end up with 2 times 5 plus 3 times 7 over 35, or 31 over 35. So what I know is that for this fraction to work, it had to have been something over x minus 3 plus something over x plus 4. That would give me this. Well, what we're going to do is kind of do similar to what we did up there and try to figure out how to make these have the same denominator. Well, to make them have the same denominator, this one I would need to multiply by the x plus 4. And this needs an x minus 3. Now remember, if I add these two together, what I'm trying to get is the 5x minus 1 over x minus 3 times x plus 4. Now it's really the numerators that would add to give me 5x minus 1. The denominators are all the same, so that's awesome. If I distributed the a right here, I'd get ax plus 4a, and then I'd have bx minus 3b equals 5x minus 1. All right, now look carefully. The parts with an x, ax plus bx would have to add to give me 5x. Ax plus bx has to give me 5x. So a plus b had better be 5. Now we also have these numbers. 4a minus 3b is going to give me negative 1. So 4a minus 3b is going to give me negative 1. I now have two linear equations with two variables each. If I took this second one and multiplied by 3, look what I would have. And I can add those together. So I get 7a equals 14. So a is 2. Remember, a plus b was 5. A plus b is 5. So b is 3. So I'm going to go back up here. A is 2. And b is 3. Pretty nifty. Try the next one. So we're going to set it up with each of the factors. Now I would need to multiply top and the bottom by x plus 2, top and the bottom by x minus 4. Now I don't need to rewrite this whole thing because I know I would distribute and then distribute. Remember, we're going to have all the terms that have x's. Ax plus bx have to combine to give me the x over here. Oh, I'll continue it in red. Ax plus bx equals x. 1x, really. So a plus b equals 1. (2a minus 4b equals 14. Now, I tend to just kind of be lazy about this since I know I've got a negative 4b here. I'm going to make this all be 4s. So times 4. So I get 4a plus 4b equals 4. So 6a equals 18. A is 3. Remember, a plus b is 1. So b is negative 2. This skill actually comes into play a lot in calculus. Now let's look at the last two examples. Notice the denominator here. I would need to factor it first. So that would be x minus 4 times x plus 3. That tells me what I'll need over here. Kind of know what's going to happen. Numbers. Now on this one I ended up getting a fraction, and that is okay. I'm going to rewrite 7 as 49/7 because then it's easier to subtract. Fractions are okay. It would just mean in my answer, instead of just having a 24 or having a 7, I'm going to have 24 over 7, which puts the 7 in the denominator.